Let's look at a couple molecules and see if we can find which one is linear. Here I have ICl2-, BrF2+, and H2S. All of them have 3 substituents, so they all have the potential to be linear. But don't be fooled. Remember, to find a linear ion or molecule, what we have to do is first draw a Lewis dot structure and get some steric numbers and see what the molecular geometry actually is. So let's do that. Here is the Lewis dot structure for those 3, H2S, BrF2, and ICl2-. Go to the steric number. Sulfur has 1, 2, 3, 4 things to accommodate, 2 lone pairs and 2 hydrogens. The bromine also has 4 things to accommodate, 2 fluorines and 2 lone pairs. So these both have steric number 4. The ICl2- has 2 chlorines and 3 lone pairs about the iodine. So that has steric number 5. Now, steric number 4 and steric number 5 give us VSEPR arrangements of tetrahedral for steric number 4 and trigonal bipyramidal for steric number 5. I have those 2 here. Here's the tetrahedral arrangement and the trigonal bipyramidal arrangement. But remember, when we're talking about the actual molecular geometry, we ignore the lone pairs. So for these 2 molecules here, there are 2 lone pairs. So you have the tetrahedral geometry, but it's as if you're going to ignore 2 of the arms. If you ignore 2 of the arms, you get a molecule that just looks bent. And that's what we say here. This molecule here, bond angle or shape, ignoring the 2 lone pairs, gives us a bent configuration. That angle is going to be something like 104 degrees, 105, 104.5, 2 lone pairs and 2 bonding pairs in a tetrahedral configuration generally gives you about 105 degrees. For our ICl2, we have 5 things. 3 of them along the equatorial positions are lone pairs, so we could ignore those. Taking off the 3 lone pairs in the equatorial position just leaves us the 2 axial chlorines. The 2 axial chlorines form a linear configuration, and that's a 180-degree bond angle. So of these 3, ICl2- is the linear ion.